Today we're going to talk about function operations. You can add, subtract, multiply, and divide functions in the same manner you would perform the same operations with real numbers. For adding and subtracting, you will sometimes see it written as f plus g of x, and all that means is you're going to take f of x and add g of x. For subtraction, you will sometimes see f minus g of x, and all that means is f of x minus g of x. Let's do an example. For example 1, we're going to let f of x equals 2x squared plus 8 and g of x equal x minus 3. There are two parts. For A, we're going to find f plus g of x, and for B, we're going to find f minus g of x. So for f plus g of x, again, that means f of x plus g of x. So what we're going to do is we're going to take f of x and put in parentheses 2x squared plus 8, and we're going to add g of x, which is x minus 3. And essentially, we're going to end up combining like terms because we're adding, so 2x squared plus 8 plus x minus 3, a couple of like terms here, to simplify and give us 2x squared plus x plus 5. Final answer. Now, with subtraction, very similar. We have f minus g of x. So we're going to have f of x in parentheses, 2x squared plus 8. And we're going to subtract g of x this time. But be careful, we need to distribute the negative. So we're going to have 2x squared plus 8 minus x plus 3. So this time when we combine like terms, we'll get 2x squared minus x plus 11. Final answer. Now multiplying and dividing functions is very simple as well. We will have f times g of x, which is the same thing as taking f of x and multiplying by g of x. We have f divided by g of x, which is f of x divided by g of x. However, here, also be careful. Remember, when we divide, you're not allowed to divide by 0. So we must create a condition so that g of x does not equal 0. In example 2, let f of x equal 3x squared minus 11x minus 4, and let g of x equal 3x plus 1. We're going to find f times g of x and f divided by g of x. So for the first one, we have f times g of x, so that means f of x times g of x. So we need to write this as 3x squared minus 11x minus 4 times 3x plus 1. So we actually are going to need to distribute. So first, take the 3x squared and distribute to 3x plus 1, and that will give us 9x cubed plus 3x squared. Repeat with negative 11x, distributing to 3x plus 1, and that will give us negative 33x squared minus 11x. And repeat once more with negative 4, distributing to 3x plus 1, to get negative 12x minus 4. So again, it's just a matter of combining like terms. 9x cubed does not have any. We've got some x squareds here, so negative 30x squared. We've got some x's, so we'll get negative 23x minus 4. Final answer. Now for division, f divided by g of x is again the same thing as f of x divided by g of x. So we're going to write that out. We'll have 3x squared minus 11x minus 4 divided by 3x plus 1. Now, it'd be really amazing if we were able to factor the numerator so that one of my factors was divisible and actually could cancel out what was in the denominator. So that's what we want to try to do. So what I'm going to do is I'm going to come off to the side here and I'm going to take my numerator, my f of x. So 3x squared minus 11x minus 4. And we're going to try and factor. Well, since my leading coefficient's not 1, we need to multiply the leading and ending terms together. So 3 times negative 4 is going to give me negative 12. So I need to find two numbers that will multiply to give me negative 12 and add to give me negative 11. We will get 3x squared. And those two numbers are going to be negative 12 and positive 1, so use those to split the middle term. And now we're going to group them. Yes, this is factoring by grouping. 3x squared and 12x have a 3x in common, leaving me with x minus 4. X and negative 4 only have a 1 in common, leaving x minus 4. And so now we have x minus 4 in common, and 3x plus 1. So what I'm going to do is I'm going to come back over to where we were dividing now, and I'm going to rewrite my numerator in factored form. So we have 3x plus 1 times x minus 4 divided by 3x plus 1. So now this is really awesome, we have 3x plus 1 and 3x plus 1 in both the numerator and the denominator. So they're going to divide and give me 1, leaving me with x minus 4. So a lot simpler than having to go through and do long division. However, remember we said that g of x, your denominator, cannot equal 0. So we need, even though we do not have a denominator in our answer, we need to go back and look at the denominator we started with. So we're going to take 3x plus 1 and set it not equal to 0. So subtract 1, divide by 3, and x is going to give me negative 1/3. So we're going to tack that on at the end of our answer, and this is our domain such that x does not equal 1/3, because if it did, our denominator would be 0 and we couldn't divide. Now we're going to talk about composite functions. The composition of a function f of x is written as g of f and is defined as g of f of x, which could also be written as g of f of x. Now, what this means is we're going to take an input value and we're going to evaluate f of x first, because it's closest to our x. Then we're going to take our solution and use that to evaluate g of x. Again, we're going to do f of x first and then use that answer to do g of x. Let's do an example, and this will make much more sense. So for example 3, we're going to let f of x equal x minus 5, and g of x is going to equal x squared. We're going to do this both ways. For a, we will find g of f of negative 3, and for b, we will find f of g of negative 3. So let's start with a. Now because this is g of f of negative 3, we're going to plug negative 3 into f first. So what I am in the habit of doing is taking f of x and rewriting it, and then plugging in my x value, in this case negative 3. So we're going to get negative 3 minus 5. Well, negative 3 minus 5 is going to give us negative 8. So now what we need to do is we're going to take this negative 8 and we're going to plug it into g of x, because again we take the solution of f of negative 3, and that's what happens to go into g of x. So now we're going to take g of x, or g of negative 8, and that's going to be x squared. So we will get negative 8 squared, which is 64. So g of f of negative 3 is 64. For b, we need to find f of g of negative 3. So this time we're going to take negative 3 and plug it into g of x first. So doing so, we're going to rewrite g of x, just copy it down. And now we're going to have g of negative 3. So that means we get negative 3 squared, which will give us 9. So then we're going to take this 9 and plug it into f of x. So f of x, as a refresher, that's going to be x minus 5. So we're going to plug 9 on in, and 9 minus 5 gives us 4. So this time, For f of g of -3, we get -4. Now the reason we did both of these is so you guys can realize that it's very important which order you do it in, because even if you plug in the same value, you will not always get the same solution. Now try these 6 problems. We're going to let f of x equal 3x minus 2 and g of x equal x squared plus 1. Again, try these 6 problems. We'll talk about them first thing tomorrow. Good luck.